All right, good. By the year 2050, over 10.7 million acres of land in the US will be occupied by solar arrays. That area is equal to the states of Massachusetts, Connecticut, and Rhode Island combined. Many of these arrays will be distributed energy resources. They'll be sited on agricultural land near centers of population for ideal interconnection into the grid. But that big solar box being removed from that agricultural box, it brings to mind images like this one, where there's a clear delineation and honestly a tension between agricultural production and renewable energy production. This tension and fear is further exacerbated by the fact that small to mid-sized farm parcels have gradually been bought up over time by large corporate producers. This trend, plus economic, social, and climate change pressures, are all coming together in a way that harms the viability of family farm operations. These factors are also contributing to a mental health crisis that is impacting our agricultural communities. Our remaining family farmers are ready for a truly regenerative approach that enriches the soil and the soul. The good news is, I think that agrivoltaics, by co-locating agriculture plus photovoltaics, can be a part of that solution. Solar grazing is the most common form of agrivoltaics. In this model, herds like this one in La Junta live on the site throughout the growing season. They work together to complete landscaping activities beneath the array. And they can also be joined by other animals like Hamish, Edith, and Peanut Butter here. They'll help to eat a wider variety of plants on site while also depositing more natural fertilizer into the soil. All those animals then go home to a family farm that's in growth mode. And that's thanks in part to the structure of contract grazing. It provides diversified revenue and consistent income for our farm partners. That gets spread throughout the season, not just once a year. All this growth in production also means growth in headcount. I think we can agree these look like some pretty happy lambs. They're really thrilled to have been born last spring on a solar site. And they're extra thrilled because these solar sites can do other good work. By planting native pollinator-friendly plants that flower throughout the season, we can also provide food and habitat for pollinators like the honeybee. Other pollinators can benefit as well, like the Kamehameha butterfly in Hawaii. This endangered species will see growth in population over time, thanks in part to a solar seed mix that includes their favorite flower, the mamaki. Now, crop production is the ultimate goal of agrivoltaics. Jack's Solar Garden right here in Longmont is a shining example of this configuration, and it's actually more repeatable than you might think. Developers and owners like Pivot Energy have found that minimal design tweaks can actually accommodate crop growth while still keeping the cost of the solar as is. So by increasing this row spacing and height by only 6 inches each, we're seeing that we can put crops on many, many of our sites. This cover crop mix is a great example, and ultimately we'll plant this here in Colorado starting next year. It'll be forage for livestock, plus root veggies and sunflowers for farmers markets. We can get more creative on crop sites too. By removing a pivot irrigation system, we can replace it with drip, thus reducing water use on site, increasing crop yields, and maintaining the water rights of the landowner. Now, thankfully, all this work is not being done in a silo. With strong, long-term relationships with great organizations like these, developers are slowly but surely deploying agrivoltaics at scale. And that's great news, because these dual-use sites have positive impacts that go far beyond the array, including carbon sequestration, access to locally grown food, and improved ecosystems. The biggest impact, though, is on the next generation of farmers. Little cowboys like this one will be able to not just survive, but thrive on their family farms and solar farms. And why not thrive on both? Because at the end of the day, we're all harvesting from the same sun, whether that's for food or fiber or photovoltaics. It's possible, and it's definitely time for every solar array to leverage agrivoltaics and to cultivate true dual harvests that benefit us all.